Question number 1. A curve C has equation y equals 2 plus 10x power half minus 2 to the 3 halves power, and x is positive value. Find dy by dx, giving your answer in simplest form. First of all, I have a function here, y equals 2 plus 10x to the power of half minus 2x power 3 halves. If you want to find the derivative dy by dx, is derivative of 2 is 0, half time, just multiply half by 10 is 5, x power negative half, minus 3 times 3, the power times 2 is 3, x power 3 over 2 minus 1 is 1 half. This is a derivative. I want this in simplest form. Just write 5 over square root of x, because x power negative half, just to bring it down, x power half, square root of x minus 3 radical x. This is the value of derivative. I'd like to find, this is number B, hence find the exact value of the gradient of the tangent at C at the point x is 2. So I'd like to find the value of the derivative dy by dx at x equals 2. Just substitute. So 5 over radical 2 minus 3 radical 2. Okay? Simplest form, just multiply the answer by this 5 radical 2, just multiplied by radical 2 up and down to simplify it. Okay? And after that, you can write 5 radical 2 over 2. Root 2 times root 2 here is 2. Minus 3 radical 2. Now the same like terms considered. So 5 over 2 minus 3, you can just take radical 2 as a common factor. So final answer is 2.5. This is 2.5 minus 3 is negative half radical 2, and this is the simplest form of the gradient of the tangent. Okay? So next one. I have 3 points P, Q, or R given its coordinate respectively here. Prove that PQR is right angle. If PQR, consider this point P, and this is Q, and this is R. This really is a right angle if the line, the angle now PQR. PQR is right angle, as you see, if we prove that PQ is perpendicular, PQ line segment is perpendicular to QR line segment. So I have to find the slope of PQ line, okay? The PQ line segment. The PQ, there's the first point is P, second one is Q, third one is R. So the slope of the PQ simply difference in y over difference in x, as you know. So 11 minus 7 over 9 minus negative 3 is plus 3. So the gradient of the line PQ is 11 minus 7 is 4, and 9 plus 3 is 12. So the gradient is 1/3. You have to find the slope of the line that is expected to be perpendicular, which is RQ. The RQ is the slope. Now work with the point RQ, okay, or QR. So 11 minus 2 over 9 minus 12, over 9 minus 12. Of course, when you find the slope, you can start with any point, the first one, second one, doesn't matter. So 11 minus 2 is really 9, okay, and the 9 minus 12 is negative 3. So 9 divided by negative 3, negative 3. And just to say, since consider this as M1, the slope, and M2 is the other slope, you just write since M1 times M2 equals 1/3 times the negative 3, which is negative 1. So the lines QP or PQ is perpendicular to the line RQ. Once you say PQ is perpendicular to RQ, it means angle PQR. So angle PQR is right angle. Okay? QR is a right angle. Okay, without, of course, drawing that figure itself. And after that, we proved already that the angle PQR is right, given that point S is such that PQRS form a rectangle. I have a point, additional point S here, such that this figure now, PQRS, the same order here, is rectangle. Find the coordinate of S. How can you find the coordinate of S? The coordinate of S, you just find it by find the relation between the coordinate of Q and R. For example, look at the Q and R. What happened from Q to R? What happened from Q to R? This line segment. From Q to R this way, let me erase this part. Okay. From Q to R, this point is Q, and this is point is Q, and this is R. What happened from Q to R? The 9 to 12, you just add 3, the x coordinate add 3, and from 11 to 2, you add 9. Yes? You add, sorry, you add negative 9. Again, from 9 to 12, or say 12 minus 9 is 3, and 2 minus 11 is negative 9. So this vector, this like a vector QR is 3 and negative 9. You just add this vector to the point P to find S. The point P, as you see here, negative 3 and 7, negative 3 and 7, this point P. Just to add the vector 3, negative 9 to this point to get the point S. So the point S is negative 3 and 7, which is the coordinate of the point P. Just add the vector QR, or the order pair 3, negative 9 to this, you will get 0, and 7 plus negative 9 is negative 2. So simply the point S must be 0 and negative 2 to be sure that this figure is a rectangle. It's already a parallelogram, but the parallelogram with right angle is a rectangle. Okay, I hope everything to be clear. So the point is 0, negative 2. Of course, there's many solutions on this part, but I like the way to use vector to solve it. Find the integral of this integration. This function or this integral need to be simplified before integration. So 4 divided by 2 is 2, and x power 5 over x squared x cubed plus 3 over 2 is still the same, but x squared, just to bring it up to be x power negative 2. I want to integrate all this expression with respect to x. So my integral is 2x power, you just add to the power 1 to the power will be 4 and divide by the same power 4, plus just write 3 over 2 and go to the x power negative 2, add 1 to the power. Negative 2 plus 1 is simply negative 1 over negative 1. And don't forget to add the constant of integration. So the integral here is 1/2 x power 4 minus, be careful, this negative must be here. So minus 3 over 2. There's really x power negative 1. You have to bring it down to be x. So minus 3 over 2x plus c, and this is the simplest form. Don't forget, a simplest form, it means don't leave any negative power and don't leave any fractional power. Something power half, for example, just leave it root x, and if you have x power negative 3, just write it 1 over x cubed, and this is exactly what meant here by simplest form. And next question is this one. Given that the equation kx squared plus 6kx plus 5 is equal to 0, where k is non-zero constant, has no real root. You remember the condition for the discriminant delta is b squared minus 4ac minus 4ac. Just I have to charge the computer before I continue. I'm sorry. Okay, 1 second. Okay, so the equation has no real roots. It means the discriminant is a negative value, less than 0. So apply this condition for the ABC, the coefficient of the terms of a quadratic equation. So b squared, 6k squared now, minus 4 times a, which is k, times c, which is 5, must be smaller than 0 or negative value. So 36 k squared minus 20k less than 0 by simplifying, by factorizing, by taking outside 4k common factor, and then divide each term by the 4k. So you have 9k minus 20 divided by 4, 5, and k over k is, so of course, 1 less than 0. So the roots I have is k0 and the k may be 5 over 9. This quadratic equation less than 0 only between the roots, because you remember that the quadratic function, if it cuts the x-axis at 2 points, 0 and 5 over 9, it has a form like this, open upward, because x squared is a positive, k squared here, it was positive value. So this function less than 0 or negative in between the roots. So k, this is the range of possible values of k bigger than 0 and smaller than 5 over 9. Thank you so much. Always the positive x squared function plus px plus c less than 0, always the solution in, if the quadratic equation has two solutions, so it always be negative in between in the two roots you have. Okay, this is if you have two roots, sorry. The next question in this part, in this exam, in this one, let's solve it with me, please. In this equation, you must show all stages of your working solution. Relying on calculator technology are not acceptable. So you have to do yourself every point of solution. Now, by substituting here, p equal 3 to the x, show that the equation this can be written in this form. So quite easy. Look at this one. 3, just write 3 times. Look, 9 power x. My students is just write it. The 9 is 3 squared. Yes, you just write 3 squared power x like this. Okay, plus 3 power x plus 2, just to bring it back one step, just write it 3 power x dot 3 power 2, okay, is equal to 1 plus 3 power x times 3 power negative 1, okay? Now, I want to replace 3 power x with the value p. Here, you can switch this, look, this is 3 power 2 all power power x. I can switch now 2 and x. For example, look, this is 2 and x. I can delete this x and this 2 and just write it again. X down here and 2 up, no problem. Now I can replace the 3, let 3 power x is equal to p. Now substitute. So 3, this is 3 power x is p, so 3p squared plus, look, 3 power x here is p. And this is 3 squared 9, so it's a 9p is equal to 1 plus p multiplied by 1/3. The 3 power negative 1 is simply 1/3, okay? So just write again, 3p squared plus 9p minus 1, bring these two terms here, minus 1 minus 1/3 p is equal to 0, and if you multiply the entire equation by 3, this is all equation multiplied by 3 to get rid of this denominator. You have 9p squared plus 3 times 9, 27p minus 3 times 1, 3. Minus 3 times 1/3 p is simply p is equal to 3 times 0 is 0. So the answer is 9p squared plus 27p minus p is 26p minus 3 is equal to 0, and this is exactly the function, the equation written here. 9p squared, this one, look, this one. 9p squared plus 26p minus 3 is equal to 0. And after that, I ask you to solve the original equation. So the original equation, I rewrite it in this form. So simply solve this equation now. I try to solve it by factorization. If not, you can solve it by quadratic formula. So just to try to factor, I have 9 times 3, 20. Yes, I can factorize because look, 9 times 3 is 27, negative 27. I can split negative 27 into two numbers. The difference between them is 26, or the sum numerically is 26 by writing 27 positive and negative 1. The sum now is 26. So just write. What I have to do is just write 9p times 1, p, and the 3, just write it here, this negative 3, make it 3 times 1. I want the middle term to be positive, make this one positive and this one negative. Now, this is the solution. So I have the middle term is correct, negative p plus 27p gives you 26p, okay? So just say either 9p minus 1 is equal to 0 or p plus 3 is equal to 0. So here, the 9p is equal to 1. Consequently, p is 1/9, or the other 1p is negative 3. Don't forget that this p, it was originally 3 power x. Don't forget the equation, it was in x. The equation you want to solve in x. So you have to bring back this substitution, and instead of each p, bring it back to be 3 power x. So now just write 3 power x is 1/9. So 3 power x is 1/3 squared, which is 3 power negative 2. By comparing now, the x is negative 2. The other one, 3 power x is negative 3. Really here we don't have, 3 is a positive number. Raised to any power, never be negative. So here, this part was no solution. No solution. It means we do not have any real value x as a power to the base of 3 and gives you the value of negative 3. So only solution is x is negative 2. Okay? I hope everything be okay with you. Write for me if you have problem in this question. Let me summarize this question for you and give you the idea to solve it and leave it to you to solve it yourself. This question now. Figure 1 shows a view for design of a stage. The design consists of a sector OBC, as you see here, OBC, with center O and joined to congruent triangle OAB. These two triangles are congruent, as you see here. BOC is 2.4. BOC, this 2.4 radians. And the area of the sector BOC is 40 meter. BOC, this area is 40 meter squared. Okay. And AOD is a straight line of length 12. Yeah. Okay. So this length is 12. Okay. So this is really the same side. So 12.5, the AOD. So you can split it into 6.25 and 6.25 logically here. Find the radius of the sector. So you remember the area of the sector. The area of the sector is rule half r square theta in radian. So just to apply this rule to find the r, so half r squared, that I don't know the r, times theta, which is 2.4, is equal to the area given 40 square meters. Okay, so simplify this one. Half 2.4 is simply 1.2 r squared is equal to 40. So r squared, just to divide 40 by 1.2, 40 over 1.2 gives you 40 divided by 1.2. The answer is 100/3. 100/3. So the r is simply a 10 over radical 3, or 10 radical 3/3 as the simplest form. So find the radius of a sector, giving your answer in 2 decimal places. You can simply just write 2 decimal places of this value. So this really 3.33. This is 100 over 3, just the square root of, the root answer is 5.77. So 5.77, this value, okay? 10 over radical 3, its value is about 5.77. Okay, this is the radius. Find the size of angle AOB in radians. AOB, where is it? AOB, yes. If you want to find this angle in radians, quite easy. These two triangles are congruent. Look, these two, look here. Triangles are congruent. So these angles are congruent consequently. Consider this angle is theta. Now I have this straight angle measured here, mentioned. Oh, okay. There's a AOD is a straight line or one straight line. So that 2 theta plus a 2.4 radians must be a 180, which is pi. Okay, so 2 theta now is equal to pi minus 2.4. So the 1 theta is pi minus 2.4 divided by 2. You can solve this one by calculator and write your answer. Just I'd like to leave you the next part of the question to be solved. Thank you so much and see you next time. Goodbye, everyone. Have a nice day.